The auto industry never stands still. We all know that. But are we about to witness a whole new revolution? More and more engineers and scientists are now shifting their focus toward finding real alternatives to fossil fuels, and they're starting to challenge everything we thought we knew. Elon Musk has pointed out many times that Tesla builds the cheapest electric motors on the market, largely because they've managed to completely eliminate rare earth materials, which are normally very expensive. But that's still not the cheapest or most groundbreaking motor Tesla may have created. Right now, there's a lot of buzz around a different kind of engine, one that could completely rewrite the rules of technology. An engine that runs on water. Yeah, you heard that right. Water could play a crucial role in powering this new engine. Now, before you get too excited, let's clear something up. It's not like you can just pour a few gallons of water into a car and drive for hundreds of miles. As fun as that sounds, that's not how a water engine actually works. Even though the term water engine sounds pretty straightforward, it's a bit misleading. In reality, these technologies mainly use water to produce or support energy, rather than using it directly as the primary fuel source. Water covers about 71% of the Earth's surface and is renewable, but the idea of turning it into enough energy to power a car still feels almost too good to be true. We all know that traditional internal combustion engines generate power by burning flammable petroleum products like gasoline. They use a spark plug to ignite the fuel, move the pistons, and power whatever device they're connected to, whether it's a car or a generator. Unfortunately, water doesn't burn. It can't produce the kind of spark needed to work inside a traditional engine. So, how does a water engine actually work? First, the vehicle or engine would have a water tank. The water needs to be pure or at least filtered to remove impurities that could damage the electrolysis system. Then, the process of electrolysis begins. Water is a molecule made up of 2 hydrogen atoms and 1 oxygen atom, and hydrogen fuel is actually one of the most powerful energy sources in the world. However, as long as those hydrogen atoms remain bonded to oxygen, they can't be used as fuel. So the first step is to separate the molecule before we can tap into the hydrogen inside. Electrolysis is the process that uses an electric current to break down water molecules into hydrogen gas and oxygen gas. The extracted hydrogen is then fed into a fuel cell inside the vehicle. In the fuel cell, hydrogen reacts with oxygen from the air, generating electricity, along with water vapor and heat as byproducts. The electricity produced powers an electric motor, which drives the wheels of the car. This electric propulsion system eliminates the need for a traditional combustion engine, resulting in 0 tailpipe emissions. Based on what we've found, it takes about 5 kilowatt-hours of electricity to produce 1 cubic meter of hydrogen gas. From just 1 liter of water, or about 0.26 gallons, you can extract around 111 grams of hydrogen, which is roughly equivalent to more than 1 cubic meter of hydrogen gas under normal conditions. To power a small car for 100 kilometers, or about 62 miles, you would need at least 1 to 1.5 kilograms of hydrogen. That means you'd have to electrolyze between 9 and 13 liters of water, or roughly 2.38 to 3.43 gallons, consuming anywhere from 50 to 180 degrees Celsius. 60 kilowatt hours of electricity. A huge amount, almost 10 times the energy it takes to fully charge a smartphone. Once you've produced the hydrogen, there are 2 main ways to use it. You can burn it in an internal combustion engine, similar to how gasoline is used, or you can feed it into a fuel cell to generate electricity and drive an electric motor. Burning hydrogen in an engine gives you an efficiency of around 25 to 35%, while fuel cells are much more efficient, reaching about 50 to 60%. In theory, a water engine sounds incredible. Just use water, an extremely cheap and abundant resource. And the only byproduct is water vapor, meaning 0 environmental pollution. If we could separate hydrogen from water easily and quickly, the water engine could completely replace gasoline, offering a clean and sustainable energy solution for the future. Some reports even suggest that compared to traditional combustion engines, water engines, through hydrogen fuel cells, offer higher energy efficiency. This means more of the energy stored in hydrogen is converted into usable energy, resulting in better fuel economy and longer driving range. However, when we take a closer look from a technical and practical standpoint, the water engine faces some major hurdles, far bigger than we might initially think. And frankly, it can't really be called an EV killer at this point. To separate hydrogen from water, a significant amount of electricity is required. The electrolysis process consumes far more energy than the hydrogen it produces, leading to very low overall efficiency. If you tried to power electrolysis directly using the car's own battery while driving, the battery would drain extremely quickly. On top of that, designing an onboard electrolysis system that's fast enough, safe enough, and compact enough to fit inside a car is extremely complicated and expensive. Hydrogen itself is also highly flammable, requiring special high-pressure tanks, which further adds to both the cost and safety concerns. Compared to today's electric vehicles, which simply charge a battery directly with high efficiency and relatively fast charging times, the water engine is far less practical and efficient. Instead of trying to split water into hydrogen on the vehicle itself, major companies like Toyota and Hyundai are taking a different approach, producing hydrogen at dedicated facilities and using fuel cell technology to generate electricity on board the vehicle. This method optimizes efficiency and reduces risk. So, while the idea of a water engine remains beautiful in theory, zero emissions, just clean water vapor. In reality, it's not yet a feasible or superior alternative compared to current, commercially viable technologies like pure battery electric vehicles or hydrogen fuel cell vehicles. When you hear that the only byproduct is water vapor, no exhaust gases, no pollution, just clean, sustainable energy, it sounds like a game-changing technology, perfectly aligned with the sustainability vision of someone like Elon Musk. However, given the many limitations and the significant amount of work still needed to make it viable, it's clear that bringing this technology into Tesla's lineup simply isn't possible right now. The truth is, Toyota already has a hydrogen-powered car on the market, the Mirai, which first launched back in 2014 and has been getting better ever since. This new wave of water engine technology takes things to an entirely new level, making it cheaper, safer, and more efficient. Toyota has remained committed to pursuing the water engine concept because they believe it could become a true game changer, especially if they can find a way to extract hydrogen using significantly less energy. On top of that, Toyota holds a major advantage when it comes to battery technology, the very technology the entire industry is racing toward. Toyota owns over 1,000 patents related to this breakthrough. Clearly, we're witnessing a major shift happening right now with the development of next-generation batteries for electric vehicles. Solid-state batteries, in particular, are being hailed as a revolution for the EV world. Toyota, one of the pioneers in this technology, has made bold claims that they plan to bring solid-state batteries into their electric vehicles by 2027. The superior features of solid-state batteries aren't just poised to transform the EV landscape. They could also pose a serious threat to Tesla's dominance with its 4680 battery technology. What is a solid-state battery? To understand solid-state batteries, we first need to understand the basic structure of a battery. All modern batteries have four main components: an anode, a cathode, a polymer plastic separator, and a liquid electrolyte. Solid-state batteries still have these same components, but the biggest difference is that the liquid electrolyte is replaced by a solid electrolyte. This key difference is what makes solid-state batteries often referred to as the battery killers of current technologies like the lithium-ion batteries that Tesla uses today. Solid-state batteries offer several major advantages over traditional lithium-ion batteries. First is energy density. Solid-state batteries can reach an energy density of up to 400 watt-hours per kilogram, far higher than the 250 watt-hours per kilogram typical of today's lithium-ion batteries, allowing them to store more energy for the same weight. This is especially crucial for electric vehicles, where both weight and efficiency are critical factors. In addition, solid-state batteries can achieve a volumetric energy density of up to 1,200 watt-hours per liter, compared to around 700 watt-hours per liter for traditional batteries. According to research from QuantumScape, the American company in which Volkswagen holds a 5% stake, their solid-state batteries have an energy density of over 1,000 watt-hours per liter, enabling electric vehicles to travel distances comparable to those of gasoline-powered cars. Moreover, solid-state batteries have a very low self-discharge rate, meaning they can hold their charge for years without significant loss, ensuring longer battery life. One of the most impressive advantages of solid-state batteries is their fast charging capability. At Tesla's supercharging stations, the 2170 battery cells can typically charge from 10% to 80% in about 30 to 40 minutes, while the newer 4680 cells can do it in just around 25 minutes. But solid-state batteries take it even further. According to data from QuantumScape, solid-state batteries can reach 80% charge in just 15 minutes. Toyota claims their solid-state batteries could charge from 10% to 80% in just 10 minutes, a charging time almost as fast as filling up a gas tank. This fast charging capability comes from the solid electrolyte in the battery, which has high ionic conductivity. This allows lithium ions to move more quickly, shortening the charging time without reducing the battery's lifespan compared to traditional lithium-ion batteries. One of the major issues with current lithium-ion batteries is the risk of fire or explosion due to the presence of a liquid electrolyte. However, solid-state batteries do not contain liquid electrolytes, so they are not exposed to the same fire and explosion risks as lithium-ion batteries. Although lithium-ion battery fires are rare, when they do occur, the consequences can be severe, sometimes requiring thousands of gallons of water to extinguish. Solid-state batteries not only offer higher thermal stability, but are also much less likely to catch fire or explode under extreme conditions, such as severe collisions. One of the driving factors behind the transformation of the automotive industry is the growing demand for electric vehicles as a replacement for internal combustion engine cars. For EVs to become a mainstream option, they must offer a driving range comparable to that of gasoline vehicles while also minimizing limitations related to charging time and battery lifespan. Currently, one way to extend an EV's range is by increasing the number of batteries. However, this method is not optimal, as it raises costs and consumes too much space inside the vehicle. A more viable solution is to develop a new type of battery that is stronger, has higher capacity, is safer, and charges faster. However, this is not an easy task. Although lithium batteries have seen many improvements, major breakthroughs in safety and performance have yet to be achieved. Despite their many advantages, solid-state batteries are still facing several major challenges. One of the biggest issues is production cost. Currently, manufacturing solid-state batteries remains very expensive because the technology is still in the developmental stage. Even though Toyota has pledged to start producing solid-state batteries by 2027, they have yet to achieve large-scale production or effectively bring costs down. Another challenge is finding a suitable solid electrolyte material that can conduct electricity well at room temperature. Additionally, there is the issue of dendrite formation, sharp, needle-like lithium metal structures that can pierce through the solid electrolyte and cause short circuits. However, researchers are actively working on solutions to overcome these problems. Solid-state batteries represent a breakthrough in battery technology, and Toyota is leading the way in their development. With a driving range of up to 745 miles per charge, charging times as short as 10 minutes, and the ability to operate across a wide range of temperatures, solid-state batteries promise to be a major step forward in reshaping the electric vehicle industry. If Toyota succeeds, they could regain a competitive edge against Tesla and even surpass other rivals like BYD. However, achieving this will require overcoming significant hurdles, from cutting production costs to ensuring long-term sustainability and safety. Even so, the future potential of solid-state batteries is undeniable, and if these challenges are addressed, electric vehicles could become the dominant choice in the global automotive market. The main reason behind the development of water engine technology is the urgent need to find alternatives to fossil fuels like gasoline and oil, which are not only expensive but also major contributors to environmental pollution. Water, being abundant and easily renewable, holds great potential as a clean energy source, helping to reduce the impacts of climate change and lessen our dependence on non-renewable energy sources. The history of water-powered car ideas shows that while many claims may be false, the drive to find green energy solutions is real and important. Toyota's continued research has produced the Mirai, a hydrogen-powered vehicle, and these advances prove that a more sustainable future for transportation is possible, and that there's still much more to come. China and the US are currently leading the electric vehicle space, but their focus remains heavily centered on batteries. If this trend continues, for decades, the demand and price for lithium could soar. China's EV market is massive, yet still heavily reliant on coal-powered electricity. The US has Tesla, but even Elon Musk hasn't fully solved the problem of battery waste. Clearly, over the long term, we need more sustainable alternatives. We're not here to claim that water engines or solid-state batteries are a guaranteed future, but we can't deny that Toyota is daring to look beyond, exploring technologies that sound almost impossible today. If Toyota's water engine project succeeds, it could leapfrog both current EV and hydrogen vehicle technologies, offering a truly sustainable alternative. But this isn't just about cars. Could Toyota's water engine replace electric vehicles? Maybe not tomorrow, but it could definitely be a game changer. Cleaner, cheaper, and more convenient than anything currently available. Toyota is actively working to reduce the cost of hydrogen production. They are partnering with various organizations to improve the production, transportation, and usage of hydrogen. For example, they are researching ways to produce hydrogen from biogas generated by chicken manure and food waste in Thailand. This approach not only provides a sustainable source of hydrogen, but also helps reduce waste and emissions. Toyota's efforts also include developing a versatile hydrogen tank concept that allows for easy installation and compatibility across different types of vehicles, helping to expand the reach of this technology within the commercial industry. While hydrogen technology has made significant strides, an engine that runs solely on water is still not viable from an energy and economic standpoint. The process of extracting hydrogen from water and then using it to generate power requires more energy than it produces. The story of the water engine serves as a reminder that the laws of physics and thermodynamics cannot be ignored. Although hydrogen holds enormous promise as a clean fuel, current production methods and technological limitations prevent a fully water-powered car from becoming a practical reality, at least for now. Research and development are ongoing, but today, the idea of a car running purely on water remains more of a dream than a near-term reality. In short, the water engine represents an important step forward in the pursuit of sustainable transportation. It offers a cleaner, cheaper, and more convenient option compared to gasoline cars and current EVs. While many challenges still lie ahead, the commitment to innovation suggests that this technology might soon become reality. What do you think about the idea of a water-powered engine? Could this be the end of EVs, or is it just a dream? Let us know your views in the comments below. And if you enjoyed this video, don't forget to like, share, and subscribe to our channel. See you in the next episode.